Today I'm going to build the circuit from problem 1.3. So first you're going to start off with a ground and a 5-volt supply. And then you're going to get a 330 ohm resistor. Drop it. And a 470 ohm resistor. It's going to be in parallel with the diode. I'm going to wire it all up. And what this is going to do is going to calculate the voltage drop after adding the diode into the circuit. The 1N 4148 diode. Do voltage, current. I'm gonna run it. So you get 12 milliamps and 7.81 millivolts. So that's what happens with the diode. Now if you remove the diode without actually deleting it, because this is a pain to put in all those parameters for the assignment, you see that the voltage is way higher, but the current is much lower. So the diode does have some internal resistance, which is a side effect of how it operates. To be able to block current in the other direction, it does have its own resistance. So it does take about a 1.9 volt drop, but it doubles the current used. And I think that's pretty interesting. You can use these circuits to test the performance of a diode, to see how much resistance it has in your circuit. Is it on the grapher? That wouldn't really show much, it doesn't move. So if you want to set this up on waveforms, pretend this resistor right here is a diode. That's the 33 ohm one, and that's the 470 ohm one, or 330 ohm one, and then this right one's the diode. You take your voltage from here, you have positive and negative at the ends, or your ground. Then you make a supply. The assignment said to set it to 1.7 volts. So I'm gonna do that here. I'm gonna limit this to half a current because it's gonna short itself. It's its favorite thing to do. Set up a scope, which I'm gonna go with 2 volts. And then I'm gonna run the supply. Scope. Oh, I need the voltmeter. Supply on. Supply is on. Oh, one of those things doesn't do anything. I keep forgetting about that. I think I have the -1 in there. Plug in the +1. That should do something. What the hell? Okay, that's weird. None of them are working. That's not a good sign. But this is how you'd set up if you wanted it to work. You want to take the voltage reading. Oh, obviously it's going to work. Little pins in the wrong spot. Just plug that back in. Keep forgetting these breadboards operate laterally and not. There it goes, you can hear it. Now you're getting the voltage. So it's dropping the 1.7 volts to 300 millivolts. Stop the supply. Yeah, that's how it works. So there's some math into solving this as well. Should be here. Should right here. So you take the voltage and you take the R2 and R1 and divide it, and then you add 470. You get basically 1 volt on this side as a voltage drop. and then you take this 0.7 volt, because that's the difference in the voltage drop, and then you times it by R1, and you get 0.3 amps at 1 volt, which should be right here in this section. And then the diode is going to take 1.54 milliamps in the forward voltage. And that's basically basically the diode takes like half the current. This was the first round of testing. See, the current's negative for the ground. You get about 0.994 millivolts, so the math is like a little bit off. And then you get a current of 0.2 or 2.1369. So the diode's taking 1.54 of that, and the resistor's taking the remaining 0.7 milliamps. And that's what happens when you do the diode. And this is the teacher setup. It's a much neater setup, but this is how you set it up if you want to solve this on your own. And that's all.